At 08:15 on August 17, 1942, 340 miles southeast of Cape Race, Newfoundland, Captain Lieutenant Werner Hartmann pressed his eye against the periscope lens of U-254. The submarine had been tracking a convoy of 23 merchant ships for 3 days, waiting for the perfect moment to strike. Everything felt familiar. Submerge at dawn, surface at dusk, attack at night. The Royal Navy's ASDEX could only detect U-boats within 3,000 yards. A patient commander running slow and deep could disappear into the ocean's natural sound. But this morning, something was different. His first watch officer called up through the conning tower hatch. Aircraft approaching from bearing 270, range approximately 8 kilometers. Hartmann swung the periscope. A twin-engine bomber was circling, too far away to have spotted them, yet it was circling as if searching for something specific. Standard procedure was to dive and wait them out. Aircraft couldn't see submarines more than 20 meters deep. Dive to 50 meter, Hartmann ordered. Slow to 4 knots, rig for silent running. The submarine became a ghost in the water, producing barely more sound than ambient ocean noise. They had done this hundreds of times. 30 minutes passed. Then something impossible happened. Through the hull, they heard splashes, small objects hitting the water's surface, perhaps 200 meters off the port beam, not depth charges. The sounds were too light, too gentle. More splashes came, forming a pattern around their position. The hydrophone operator whispered urgently, "I'm picking up strange transmissions, very high-frequency radio signals, coming from the surface directly above us." Radio signals from the surface. That made no sense. Surface ships and submarines couldn't communicate via radio underwater. Radio waves didn't penetrate seawater beyond a few meters. "Are you certain?" "Jawohl, Herr Kapitän. Multiple sources, all transmitting continuously on different frequencies. They sound like beacons." Another splash, closer this time. The aircraft was dropping something systematically, creating a grid pattern across the ocean's surface. Whatever these objects were, they weren't weapons. They were floating, listening, broadcasting. Hartmann made a decision based on decades of naval doctrine. If they couldn't hear him, they couldn't find him. He would wait them out at depth, maintaining absolute silence. But the aircraft didn't leave. For the next 4 hours it circled overhead, occasionally dropping more of these mysterious objects. U-254's crew stood at their stations in perfect silence. The submarine drifted with the current, making no sound beyond the faint hum of electric motors turning at bare minimum speed. Then, at 13:45 hours, everything changed. The first depth charge exploded 500 meters astern, not close enough to damage, but far too close to be random. A second explosion followed, 300 meters to starboard. They were being triangulated, hunted by an aircraft that somehow knew their exact position, despite the U-boat being invisible beneath 50 meters of grey Atlantic water. "They can hear us," Hartmann said, his voice steady despite the ice in his veins. "Somehow they can hear us." Another depth charge, closer still. Then a pattern of 6 walking across the ocean floor toward their position with mathematical precision. The aircraft couldn't see them. It had no ASDIC, yet it was tracking their every move as if reading their position from a map. After 6 hours of this underwater nightmare, U-254 finally escaped by running east at full speed, draining their batteries to put distance between themselves and whatever devilish technology the Americans had deployed. When they finally surfaced that night, 90 kilometers from the attack site, Hartmann immediately drafted a report for BDU, U-Boat Command in Paris. Attacked by aircraft using unknown detection method. Submarine tracked continuously for 6 hours, while submerged and running silent at 50 meters. Conventional explanation impossible. Request intelligence assessment. The response from Admiral Dunitz's headquarters came 3 days later, and it was dismissive. Aircraft probably used chance visual sighting before dive. Depth charge patterns were random. Maintain proper silent running procedures. BDU has no intelligence indicating new Allied detection capabilities. But Captain Lieutenant Werner Hartmann knew what he had experienced. The Americans hadn't been guessing. They had been listening. And whatever technology allowed them to hear a silent submarine from miles away represented something far more dangerous than radar or ASDIC. This is the story of how a device costing $65 ended submarine invisibility, how American engineers mass-produced 150,000 Sonobuoys that could hear U-boats from 20 miles away, and how the psychological terror of being heard from the depths destroyed German morale faster than depth charges ever could. The story of the Sonobuoy began not with brilliant German engineering or centuries of naval tradition, but with a British scientist making a suggestion that most experts immediately dismissed as impractical. In May 1941, Professor P.M.S. Blackett, head of the British Admiralty's Committee for Anti-Submarine Measures, proposed a radical idea. What if you could drop expendable sonar devices from aircraft to listen for submarines? These devices would float on the surface, listening to underwater sounds, and transmit what they heard via radio back to circling aircraft. The concept was elegant. Aircraft could cover vast areas of ocean quickly, but couldn't see submarines once they submerged. Surface ships had sonar, but moved slowly and made so much noise themselves that submarines could hear them coming from miles away. But a small passive listening device dropped from aircraft could combine the mobility of air power with the underwater detection capabilities of sonar, all while making almost no noise itself. British naval experts immediately identified numerous technical problems. The buoys would need to be small enough to carry in quantity, rugged enough to survive being dropped from aircraft, waterproof enough to function in the ocean, and equipped with both a hydrophone to listen underwater and a radio transmitter to broadcast what they heard. They would need batteries that could last for hours. And somehow all of this technology would have to be packed into a device cheap enough to be truly expendable. Because once dropped, these buoys would never be recovered. Interesting in theory, one British naval engineer noted in a memorandum, but the technical challenges are insurmountable within any reasonable time frame. The Americans, however, thought differently. In June 1941, before the United States had even entered the war, the Office of Scientific Research and Development awarded a contract to RCA in Camden, New Jersey, to develop exactly such a device. The goal wasn't perfection. It wasn't German-style precision engineering. It was something much more American. Make something that works well enough, make it simple enough to mass produce, and make it cheap enough to drop by the thousands. By March 1942, just 3 months after Pearl Harbor, a prototype existed. The device was crude by pre-war standards. A simple hydrophone hung from a floating canister containing batteries, a radio transmitter, and an antenna. When dropped from an aircraft by parachute, the parachute itself would pull a switch to activate the buoy. The hydrophone would descend about 30 feet below the surface, listening to any sounds in the water. Those sounds would be transmitted via radio back to the aircraft. The first operational test occurred on March 7, 1942. Navy blimp K-5, cruising over waters south of New London, Connecticut, successfully detected the American submarine S-20 running completely submerged using one of these prototype buoys. Detection range, 3 nautical miles. 3 miles. A submarine commander could be running silent, making almost no sound, following every procedure in the doctrine manuals, and an aircraft overhead could hear him from 3 miles away, not see him, not detect him with radar, actually hear him. Listening to the faint sounds of his propellers, his machinery, even the water flow over his hull. The implications were staggering, but almost no one in U-boat command grasped them immediately. By June 1942, the AN/CRT-1 Sonobuoy entered mass production. By August the same month, Captain Lieutenant Hartmann encountered them. American aircraft were deploying them operationally in the Atlantic. The buoys had 6 available radio frequencies, allowing aircraft to drop multiple buoys and listen to each one separately. They could operate continuously for 6 hours. They cost approximately $65 each. $65 for a weapon that could strip away submarine invisibility. While U-boat commanders in the Atlantic were having mysterious and unsettling encounters with these new devices, the most dramatic demonstration of Sonobuoy technology was still 2 years away. And it would involve not a German submarine, but a Japanese one. On March 10, 1944, the massive Japanese submarine I-52 departed Kure Naval Base on her maiden voyage. Bound for German-occupied France, she was a monster of a boat, 356 feet long, displacing 2,564 tons, with a crew of 94 men. Her cargo hold contained 11 tons of tungsten, almost 10 tons of molybdenum, 3 tons of opium, 54 kilograms of pure caffeine, and most significantly, 146 gold bars weighing 2.2 tons. Payment for German optical and radar technology. The journey was over 15,000 nautical miles, through some of the most dangerous waters in the world. I-52 traveled submerged during the day, surfacing only at night to run her diesel engines, recharge batteries, and ventilate the boat. She made stops in Singapore to take on 120 tons of tin, 60 tons of rubber, and 3.3 tons of quinine, then headed west across the Indian Ocean. American codebreakers monitored her progress every step of the way. Commander Uno Kameo, I-52's captain, had been told that the Allies couldn't break Japanese naval codes. He'd been told that submarines operating far from land were nearly impossible to track. He'd been told that the middle of the Atlantic Ocean, thousands of miles from any base, was essentially safe. He'd been told wrong. On June 6, 1944, D-Day, the Japanese naval attaché in Berlin, sent I-52 a warning. The Allied landings in Normandy had made Lorient, France, too dangerous. I-52 should plan to head for Norway instead. But first, she was to rendezvous with German U-boat U-530 on June 22nd at coordinates 15 degrees north, 40 degrees west, to receive radar detection equipment and 2 German radio technicians who would help install it. Commander Uno acknowledged the message, fatally including his exact position in the reply. American intelligence intercepted that transmission within minutes. A hunter-killer task force centered around the escort carrier USS Bogue, commanded by Captain Aurelius B. Vosseler, was en route from Europe to the United States. The task force included 5 destroyer escorts and carried 9 FM-2 Wildcat fighters and 12 TBF-1C Avenger torpedo bombers. This group had already sunk 13 enemy submarines over the previous year. They were extremely good at their job. F-21 submarine tracking room in Washington immediately began vectoring the Bogue group toward the rendezvous point. The Americans wouldn't just sink I-52. They would let her meet with U-530, allowing the German submarine to transfer equipment and personnel, and only then would they strike. The goal was to demonstrate that even in the middle of the Atlantic Ocean, even at night, even with every advantage of surprise and stealth, submarines could no longer hide. On the night of June 23, 1944, about 850 nautical miles west of the Cape Verde Islands, U-530 surfaced and began the rendezvous. I-52 approached cautiously, her diesel engines rumbling as she ran on the surface at 15 knots. The sea was rough, visibility poor. Commander Uno probably felt as safe as any submarine captain could feel in 1944. Thousands of miles from the nearest Allied base, in the middle of a dark ocean, during a rendezvous that only Japanese and German commands knew about, except Allied command knew about it too. At 22:40 hours, 3 TBF Avenger bombers launched from USS Bogue and headed toward the rendezvous coordinates. They were led by Lieutenant Commander Jesse D. Taylor, a veteran patrol pilot who had participated in multiple submarine kills. His aircraft was equipped with the latest ASV radar for surface detection, and in his bomb bay, he carried something that would have fascinated and terrified every U-boat commander in the Atlantic. 16 CRT-1 Sonobuoys, U-530 completed the transfer. 2 German technicians, petty officers Schultz and Behrens, plus radar detection equipment, and departed the area at high speed, heading for Trinidad. The submarines had been on the surface together for less than 2 hours. Commander Uno, satisfied that the rendezvous had been successful and undetected, kept I-52 on the surface to make good speed toward Europe. The submarine's diesels were loud, churning white water in the submarine's wake as she pushed through moderate swells at 15 knots. Her radar detection equipment was still packed in crates, not yet installed. The 2 German technicians were settling into the cramped submarine's interior, probably grateful to be aboard a boat bound for Europe rather than remaining in the South Atlantic. At 23:40 hours, Taylor's Avenger picked up I-52 on radar at a range of 12 miles. The submarine was completely unaware. No warnings, no alerts, just a large metal object on the surface, sending back beautiful radar returns to an aircraft that was invisible in the darkness overhead. Taylor approached, dropped flares to illuminate the target, and the submarine immediately crash-dived. Commander Uno's training and instinct took over. Surface contacts meant danger, and the only safety was underwater. Within 90 seconds, I-52 was completely submerged, running south at maximum underwater speed. This is where the new technology proved its worth. As I-52 dove, Taylor's crew began dropping sonobuoys in a precise pattern around the submarine's last known position. Purple-coded buoy, orange, blue, red. Each buoy transmitted on a different frequency, and Taylor's radio operator could switch between them rapidly, listening to each one in succession. The principle was simple, but devastating. By listening to the relative loudness of the submarine's propeller noise on different buoys, Taylor could determine exactly which direction the submarine was moving. By noting how the sound intensity changed on each buoy over time, he could calculate its speed. The submarine thought it was invisible, running silent beneath the waves. Instead, it was broadcasting its position continuously to anyone with the equipment to listen. At 23:48 hours, Taylor dropped two 354-pound Mark 54 depth bombs. Set to explode at 25 feet depth, his gunner saw one bomb explode almost directly over the submarine's starboard side, the explosion sending a column of water 30 feet into the air. A near miss, but not close enough to kill. I-52 went deeper and turned hard to port, trying to evade. Commander Uno probably thought he'd been lucky, that the aircraft had lost contact when he dived, that the bombs were dropped on his estimated position, rather than his actual position. But Taylor's sonobuoys could still hear him. The Americans could hear every turn of the submarine's propeller screws, could hear the flow noise from water rushing over the hull, could even hear machinery operating inside the pressure hull. The submarine was 200 feet below the surface, invisible to every sense except one: sound. At 23:52 hours, Taylor dropped something else, a Mark 24 acoustic homing torpedo, codenamed Fido. This was the first Allied acoustic torpedo, developed by the Harvard Underwater Sound Laboratory. Unlike conventional torpedoes that ran straight, Fido would listen for the loudest sound in the water and steer toward it. In the empty Atlantic, far from shipping lanes, the loudest sound was I-52's propellers. The torpedo entered the water, its own acoustic sensors activated, and it turned immediately toward its target. Commander Uno never saw it coming. The Mark 24 didn't announce itself with engine noise or a visible wake. It simply homed silently on the submarine's own sounds, getting closer and closer until it was too late to evade. The explosion was heard clearly on Taylor's sonobuoys, a loud crack, followed by the unmistakable sound of a pressure hull rupturing, metal twisting, compartments flooding, bulkheads collapsing. The recording exists to this day in the U.S. National Archives. The last moments of I-52, captured by devices no bigger than a milk bottle floating on the surface. But the story doesn't end there. As Taylor's patrol time ended, he was relieved by Lieutenant Junior Grade William Flash Gordon, accompanied by civilian underwater sound expert Price Fish. They arrived on scene just after midnight on June 24th and continued listening to the sonobuoys that were still operating. At 0100 hours, Fish reported something extraordinary. "Sir, I'm picking up faint propeller noise in the area. It sounds like there's still a submarine running." Gordon checked with Taylor about the exact position of the sonobuoys, then dropped another Fido torpedo where the sound seemed strongest. At 0213 hours, Gordon and his crew heard a second submarine breaking up underwater. Except there was no second submarine. Taylor had definitely sunk I-52. Decades later, when analysts at Johns Hopkins University Applied Physics Laboratory studied the original wire recordings from that night, they realized what had happened. The propeller sounds Gordon heard weren't from I-52. They were from U-530, the German submarine that had transferred equipment and then fled the scene. U-530 was nearly 20 miles away by that point. 20 miles, and Gordon's sonobuoys could still hear it clearly enough to track it, to distinguish its propeller sounds from ocean noise, to create a firing solution for a torpedo. The sonobuoys were detecting U-530 through a phenomenon called a surface duct. a quirk of underwater sound propagation where a layer of water near the surface acts like a waveguide, channeling sounds for incredible distances. Under the right conditions, a quiet submarine running at moderate speed could be heard not just 3 miles away, as the early tests had shown, but 20 miles away. 20 miles of detection range. From a device that cost $65, that could be carried by the dozens on a single aircraft. That could be dropped in patterns to create underwater surveillance networks covering hundreds of square miles of ocean. The age of submarine invisibility was over. September 14th, 1943. U-Boat Command Headquarters, Paris. Korvettenkapitän Hinrich Lehmann-Willenbrock stood before the massive plotting table in the operations room, studying the latest loss reports with growing unease. As a staff officer responsible for tactical analysis, his job was to identify patterns in Allied anti-submarine capabilities and recommend countermeasures. What he was seeing in the autumn of 1943 made no sense according to traditional naval doctrine. In the past 60 days, 17 U-boats had been lost to aircraft attacks while submerged, not surfaced and caught by surprise. That was an occupational hazard every commander understood. These boats had successfully crash-dived, gone deep, rigged for silent running, followed every procedure perfectly, and were still being hunted with uncanny accuracy by aircraft that had no business knowing where they were. A younger analyst approached with another folder. The report from U-338. Captain Lieutenant Kinzel states he was tracked for 4 hours while running at 70 meters depth. Speed 3 knots. The aircraft dropped objects into the water. Small splashes, not depth charges, and then proceeded to attack his position with remarkable precision. Lehmann-Willenbrock took the report, reading Kinzel's careful description. It matched a dozen others he'd reviewed that week. Small objects dropped from aircraft. Multiple radio transmissions on different frequencies emanating from the drop sites. Accurate depth charge patterns following immediately afterward, even when the submarine maintained absolute silence. Has Berlin provided any technical assessment? Berlin insists this is impossible. Their experts claim radio waves cannot penetrate seawater. Therefore, these reports of surface radio transmissions are misidentifications. They suggest the commanders are hearing their own equipment or are mistaking electrical interference for enemy transmissions. But 17 boats, 17 different commanders, all reporting the same phenomenon. These are not inexperienced men seeing phantoms. Lehmann-Willenbrock nodded slowly. He'd commanded U-96 earlier in the war, had experienced enough combat to trust the instincts of veteran commanders. When experienced officers reported something consistently, you didn't dismiss it as mass delusion. Prepare a comprehensive analysis, he ordered. Compile every report mentioning these mysterious splashes, these radio transmissions, these impossibly accurate aircraft attacks on submerged submarines. I want timelines, locations, weather conditions, everything. Admiral Dönitz needs to see this pattern, and he needs to see it now. What Lehmann-Willenbrock didn't know, what no one in the Kriegsmarine fully understood yet, was that they were already 9 months behind the technological curve. The Americans hadn't just developed Sonobuoys, they'd refined them, deployed them by the thousands, trained hundreds of air crews in their use, and were systematically stripping away the Atlantic's hiding places. Between August 1942 and September 1943, American and British forces had ordered over 150,000 Sonobuoys. Production facilities were churning them out at rates that would have seemed impossible to German war planners, accustomed to careful manufacturing and quality control. The Americans were treating these sophisticated electronic devices like ammunition, expendable, mass-produced, used in vast quantities without regard for recovery or reuse. The psychological impact on U-boat crews was mounting faster than BDU could assess it. October 2nd, 1943. Bay of Biscay, approaching the French coast. Oberleutnant zur See. Martin Fischer pressed himself against the conning tower fairwater, binoculars scanning the grey sky for any sign of aircraft. U-603 was 3 hours from base at Lorient. Having survived a grueling 42-day patrol in the North Atlantic that had yielded exactly 0 sinkings and 2 near-death experiences with Allied aircraft. The Bay of Biscay crossing was the most dangerous part of any U-boat's journey. Allied aircraft patrolled these waters constantly, and submarines had to transit on the surface to make good speed toward the safety of French ports. Every commander knew the risks. What Fisher didn't know was that his boat was already being tracked. 12 miles to the north, a British Sunderland flying boat had dropped a pattern of 6 Sonobuoys 30 minutes earlier, creating a detection net across U-603's likely approach path. The submarine wasn't even visible on the horizon. The Sunderland's crew was simply gambling that U-boats would use this particular corridor, and they'd set up their underwater listening posts accordingly. When U-603 passed within 2 miles of the Sonobuoy line, the hydrophones picked up the distinctive sound of a Type 7C U-boat running at 14 knots. The Sunderland's radio operator, hearing the clear propeller beats through his headphones, immediately alerted the pilot. Contact bearing 185, range approximately 3 kilometers based on signal strength, definite submarine, likely running submerged at periscope depth based on sound characteristics. Flight Lieutenant David Morrison banked the massive flying boat toward the bearing. U-603 wasn't actually submerged. Fisher was running on the surface to make better speed, but that detail didn't matter. The Sonobuoys had detected the submarine from miles away, and now Morrison had a precise vector to intercept. "There!" Morrison's co-pilot pointed, a small grey shape on the grey water, barely visible even at 2 miles range, U-boat running on the surface. Fisher saw the Sunderland at the same moment and screamed the alarm. "Flieger alarm! Dive! Dive! All hands below!" The klaxon blared. Men scrambled down hatches, the diesels cut off and electric motors engaged. Vents opened and the tanks began flooding. U-603 nosed downward in the emergency crash dive that every U-boat crew had practiced hundreds of times. But this time they didn't escape into the ocean's anonymity. As U-603 submerged, Morrison's crew dropped 8 more Sonobuoys in a tight pattern around the dive point. They didn't need to see where the submarine went. They could hear it. Every movement, every course change, every attempt to evade was broadcast back to the circling Sunderland through the underwater listening network. "He's going deep," the radio operator reported. Switching between Sonobuoy frequencies, bearing now 192, speed approximately 8 knots, depth increasing, sounds like he's going below 50 meters. Fisher pushed U-603 to 70 meters, then 80, trying to get below the thermocline layer, where he hoped the temperature difference would disrupt whatever sensing equipment the British were using. The boat's speed slowed to 4 knots, barely making steerage way. Absolute silence throughout the submarine. Men breathed shallowly, no unnecessary movement. The depth charges began falling exactly 10 minutes after the dive. The first pattern of 4 charges exploded in a perfect square around U-603's position, each explosion close enough to shake the hull violently, but not close enough to rupture it. Fisher immediately ordered a course change to starboard. Then, 30 seconds later, a change to port. Classic evasion tactics. The second pattern of depth charges bracketed his new position perfectly. "Mein Gott," Fisher whispered. "They're following us. They know exactly where we are." Matt-Johann Richter, the hydrophone operator, was crying quietly at his station, his hands shaking as he held his headphones. "Herr Oberleutnant, I can hear more splashes. They're dropping more of those things. We're surrounded by them." For 6 hours, the Sunderland stalked U-603 like a cat toying with a mouse. The submarine would change course. The depth charges would follow. It would change speed. The explosions would adjust accordingly. Fisher tried every trick he knew: silent running, rapid course changes, taking the boat deep, then shallow, even blowing a bubble decoy from the torpedo tubes in hopes of creating a false acoustic signature. Nothing worked. The Sonobuoys could distinguish between the submarine's real propeller signature and the artificial bubble cloud. They could track the boat at any depth within their hearing range. They could follow course changes because Fisher had to use his propellers to turn. And propellers made noise. And noise was what the system was designed to detect. At 1547 hours, with batteries nearly depleted, compressed air running low, and the crew on the edge of psychological breakdown, Fisher made the decision to surface and fight. Better to die facing the enemy than to slowly suffocate as a hunted animal in the deep. U-603 breached the surface like a wounded whale, water streaming from her conning tower. The deck guns were already manned as the boat completed her emergency surfacing, but the Sunderland was waiting, positioned perfectly, and its depth charges were already falling as U-603's conning tower cleared the water. The charges exploded alongside the submarine, blowing massive holes in her pressure hull. U-603 lasted less than 3 minutes on the surface before sinking stern first, taking 38 men with her. Only 9 survived, picked up by a British destroyer 2 hours later. Among the survivors was Mart Johan Richter, the hydrophone operator. During his interrogation at a British POW camp, he would tell his captors something that appeared in intelligence reports within days. We couldn't hide from them. They could hear us wherever we went. Whatever device they were using, it took away the ocean. The ocean used to protect us. Now it betrays us. Every sound we make, they can hear. How do you fight an enemy that can hear through miles of water? November 1943. Interrogation of U-boat prisoners. British Naval Intelligence. Commander Peter Chalmers of British Naval Intelligence sat across from Captain Lieutenant Georg Schneider, formerly of U-521. Sunk by Canadian forces off Halifax 3 weeks earlier. Schneider was 34 years old, a career naval officer, holder of the Iron Cross First Class, and a veteran of 9 war patrols. He was also visibly shaken in a way that Chalmers had not seen in earlier prisoners. "Tell me about your last patrol," Chalmers prompted gently. Schneider stared at his hands for a long moment before speaking. "We lasted 11 days. 11 days from the time we cleared the French coast until we were sunk. We never fired a torpedo. We never even saw a target worthy of attack. We spent 11 days hiding from aircraft that could somehow find us no matter what we did. How do you think they found you?" "I don't think, Commander. I know. They have devices, floating devices they drop from aircraft, small cylinders. We could hear them splashing into the water around us. And once they were in the water, we couldn't escape. Every time we moved, every time we changed course or depth, the aircraft knew. They followed us underwater as if they could see through the ocean." Chalmers made notes, his expression neutral. "Your acoustic torpedoes, the Zaunkönig, were they effective?" Schneider laughed bitterly. "We never got close enough to escorts to use them. The aircraft found us first, always. Do you understand what that means? In 1941, in 1942, we hunted convoys. We stalked them for days, positioned ourselves for attack, chose our targets. Now we are the targets. We are hunted from the moment we leave port until the moment we die." "How does this affect crew morale?" "Morale?" Schneider's voice rose slightly. "Commander, men are volunteering for punishment duties rather than submarine service. Submarine duty used to be an honor, a mark of elite status. Now it's a death sentence, and everyone knows it. On my boat, 3 men attempted to injure themselves seriously enough to be left behind before our last patrol. We caught them, but I understood why they did it. They wanted to live." Chalmers leaned forward. "What would you tell other U-boat commanders if you could?" Schneider met his eyes directly. "I would tell them the truth. The ocean no longer hides us. Whatever technology the Allies have developed, it has made submarines obsolete, not inferior, obsolete. We are blind men stumbling in a room full of enemies who can see perfectly, and there is no counter to this, no tactic, no procedure. No amount of training or courage can overcome being heard from miles away, while you cannot hear your enemy at all." The interrogation report, like dozens of others, made its way to Allied intelligence summaries. Similar reports came from captured German sailors across the Atlantic. The pattern was clear. U-boat morale was collapsing under the psychological pressure of being hunted by an enemy that could detect them through means they couldn't comprehend. The numbers told a story more clearly than any individual combat report. In 1942, before Sonobuoys entered widespread service, Allied aircraft sank 34 U-boats while the submarines were submerged. In 1943, with Sonobuoys in regular use, that number rose to 127. By the first quarter of 1944, aircraft were sinking submerged U-boats at a rate that exceeded German shipyard production capacity. The kill rate per attack had also shifted dramatically. In 1942, it took an average of 87 aircraft attacks to sink 1 submarine. By 1944, That ratio had improved to 16-1. The difference was almost entirely attributable to improved detection, specifically the ability to track submerged submarines using sonobuoys and then prosecute those contacts with acoustic homing torpedoes. But perhaps more significant than the kills were the non-kills. Submarines detected and forced to evade. Submarines driven away from convoy routes. Submarines that abandoned attacks because they knew they'd been detected. U-boats were spending more time submerged, more time hiding, more time trying to evade detection, and correspondingly, less time in positions to attack Allied shipping. In January 1942, German U-boats sank 62 Allied ships totaling 327,357 tons. In January 1944, despite having more U-boats operational, they sank 16 ships totaling 79,649 tons. The decline wasn't due to lack of targets. Allied convoys were crossing the Atlantic constantly. It was due to submarines being unable to reach attack positions without being detected, tracked, and driven off or killed. Captain Roger Wynne, director of the British Admiralty's Submarine Tracking Room, summarized the situation in a memorandum dated March 15, 1944. The introduction of airborne passive acoustic detection has fundamentally altered the strategic balance in the Battle of the Atlantic. German submarines no longer possess the initiative. They are reactive, defensive, and demoralized. Even when our aircraft do not achieve kills, they achieve the strategic goal of rendering U-boats combat ineffective through continuous surveillance pressure. A submarine that spends 90% of its patrol time evading detection is a submarine that poses minimal threat to our convoys. The memo went on to note something else. German prisoners consistently reported that the psychological impact of being heard was worse than the physical danger of depth charges. The knowledge that they were being monitored, that their movements were being tracked by invisible listeners, that nowhere in the ocean was truly safe. This knowledge eroded morale faster than combat losses. Some captured U-boat crewmen reported nightmares about the Sonobuoys. Others described paranoia, believing they could hear the devices transmitting even when logic suggested none were nearby. A few exhibited symptoms that British medical officers classified as acoustic trauma syndrome, a form of psychological breakdown specific to the terror of being hunted by sound. May 7, 1945. Captain Lieutenant Eric Topp stood on the concrete dock, looking at U-2540, one of the new Type 21 boats that was supposed to revolutionize submarine warfare. She was sleek, modern, capable of running submerged at 17 knots, faster than most surface ships. She had massive battery capacity that allowed her to remain underwater for days at a time. She represented everything German engineering had learned about submarine design over 5 years of brutal combat. None of it mattered anymore. The war in Europe would end in 3 days. Admiral Dönitz would order all U-boats to surface and surrender. The Battle of the Atlantic was over, and the U-boats had lost. Topp thought about the Sonobuoys, about those small floating cylinders that had contributed so significantly to this defeat. They weren't sophisticated, they weren't precision-engineered masterpieces, they were mass-produced American industrial products, crude but effective. And there had been so many of them that U-boats couldn't avoid them. That was the lesson, Topp realized. The Americans hadn't defeated the U-boats through superior tactics, or better-trained crews or more courageous commanders. They defeated the U-boats by making detection cheap, reliable, and ubiquitous. They turned ocean surveillance into an industrial process, manufacturing detection devices by the hundreds of thousands, and deploying them across the entire Atlantic. A German approach would have been to develop a few extremely sophisticated sonobuoys, carefully engineered, thoroughly tested, operated by highly trained specialists. An American approach was to make thousands of good enough sonobuoys, spread them everywhere, and let quantity compensate for any individual unit's limitations. The Americans had been right. Quantity was its own quality when you had enough of it. That evening, Topp wrote in his personal journal, "We lost the Atlantic not to British courage or American determination, but to American production capacity. They built weapons faster than we could sink ships, produced detection devices faster than we could evade them, and trained new air crews faster than we could kill experienced ones. We were fighting an industrial system, not just an enemy navy, and no amount of German tactical brilliance could overcome the simple mathematics of American industrial output. 3 days later, U-2540 surfaced for the last time, flying a black flag of surrender. Her crew was taken into custody. The boat herself would eventually become a museum. The war was over. In the final accounting, Sonobuoys contributed to the sinking or forcing to surface of over 150 U-boats between 1942 and 1945. More significantly, they contributed to the failure of hundreds of U-boat patrols that never made attacks because submarines were detected, tracked and driven away from their intended targets. The total cost of the Sonobuoy program, approximately $9.75 million for 150,000 units deployed during the war, less than the cost of a single large warship. In exchange, the Allies gained a surveillance network that covered the entire Atlantic and contributed decisively to winning the Battle of the Atlantic. The psychological impact lasted long after the war ended. Former U-boat commanders interviewed in the 1950s and 1960s consistently cited the Sonobuoy as one of the most terrifying weapons they'd faced, not because they were deadly, depth charges and torpedoes were deadlier, but because they removed the ocean's protection. They made submarines visible in a domain where visibility had always meant death. Fregattenkapitan Walter Köhler, who survived the war and later wrote a memoir, summarized it this way: "We Germans believed that warfare was about quality, superior training, better tactics, more advanced technology. The Americans taught us that warfare at industrial scale is about quantity, production, and systematic deployment. Their Sonobuoys were simple devices, nothing a German engineer would have been proud of, but there were thousands of them, and that made all the difference. We lost not because they built something we couldn't match, but because they built more of it than we could possibly evade. In the end, the ocean itself became our enemy. And the Sonobuoys were simply the technology that turned water into ears. We couldn't hide, couldn't run, couldn't fight back against listeners we couldn't find. That was the true revolution, not the technology itself, but the willingness to use it in overwhelming numbers, without concern for cost or recovery. Very American, very effective, very much the reason we lost. If this story moved you the way it moved us, do me a favor. Hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about technology that changed warfare. Stories about submariners who realized too late they could be heard from 20 miles away. Stories about how $65 devices defeated billion-dollar submarine fleets. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, Germany, the United Kingdom, Japan? Our community stretches across the entire world. You're not just a viewer. You're part of keeping these memories alive. Tell us your location. Tell us if someone in your family served in submarines or anti-submarine warfare. Just let us know you're here. Thank you for watching. And thank you for making sure these stories of technological revolution and human courage don't disappear into silence. The men who fought in U-boats and the men who hunted them deserve to be remembered. And you're helping make that happen.